Hello, I'm Rex Childhouse, and because things on the internet seem to lose their date references and I have a puppy with me, today is Tuesday, November 5th, 2024. And on September 4th, which was a Wednesday, 2024, we visited the Johnson Space Center in Houston, Texas. And this video is about our tour. We spent about 4 to 4.5 hours there. I wish we could have spent more time, but we are on a schedule and moving from the West Coast to the East Coast, touring a whole lot of places of interest as we went. This museum charges you for parking, or visitor center, charges you for parking, charges you for admission, and I will tell you, I don't think it's really cheap, but it is good, and it has numerous sections to it, and I'm going to show you most of those sections. And briefly, they are a replica of a space shuttle. I think it was actually a trainer space shuttle. The shuttle transport, or the shuttle carrier aircraft, 747, one of two that carried the shuttle around. A Saturn V missile that is off in its own building, taken into the various stages and explained very, very well. Two different missile parks with various missiles in them. A presentation on, and there's a Falcon 9 in one of the missile parks. A presentation on what we're doing about going to the moon. Presentation on what we're doing about going to Mars. And then some other stuff along the way. It was extremely informative. The signage is very good. I think it's child friendly. I enjoyed it. My wife enjoyed it. I wish we would have had more time, but we were on a schedule. If we get back through there again, we might do it again. Thanks for watching. Hope you enjoyed it, and there's more to come in our 38-day vacation. I think we did something like 58 points of interest. So there's more to come. Thanks for watching. Hope to see you in another one. This is going to be an orientation, I guess, the best way to phrase it, of the Johnson Space Center in Houston, Texas. And I think it's now run by contractors. It's not run by the U.S. government. The tickets don't sell that way, whatever. And there are several major sections to the Space Center, and the tickets. Parking is free. The parking is not free. You have to pay for parking. Admission is not free. And if you want to do any of the special tours, they cost buku bucks. We were not interested. We did take the free shuttle over to the Saturn V bay, which you'll see in this video. And we did roam around this building in particular. There's two major buildings, and then what I would call a missile park that you can roam around, and the space shuttle carrier aircraft, and a replica of a space shuttle. The first thing that we toured, I guess, in detail was the replica of the shuttle, and there was it was very effectively turned into an educational exhibit, talking about the various things that the shuttle did, like carry the satellites up, did the repairs, helped do a number of things like untangle solar panels at the International Space Station, things like that, and how they lived on the shuttle for the not extremely long time that they spent in space. It was pretty cool. We had a pretty darn good view of various parts of the space shuttle, and including the flight deck itself. And I was looking at it, and there's quite a bit of instrumentation in the flight deck. But I suspect that, like most aircraft, you don't use very much of it in any one portion of flight. Use 20% of it in takeoff, 20% of it in the climb out, 20% of it during cruise, 20% of the at the initial starting of the descent, and then 20% at the end. I've flown some pretty complex aircraft, and once you get used to them, you realize that there's a flow to the cockpit, and not everything is used all the time. So it's intimidating to look at, but I suspect it's not extremely difficult to operate. Some of what they were displaying was kind of humorous, and in an effort to blow off some of the stress. Some of the factors, like the ejection seat that was on the earliest one, but not on the operational ones that went into space. So the signage in the space shuttle was fantastic, and you could walk around on the outside of it, around on their access, on their stairs, on their whatever you want to call them, the thing that got you up to it, and you can get some pretty good views of it. And on the inside of the building was another exhibit associated with the space shuttle. And they did address the physics of the shuttle and the shuttle carrier aircraft, the 747 that carried the shuttle around. Why did it have a tail cone during transport, not during the drop test? Because they wanted the actual drag of the drop test. And things along the line of, when the shuttle went into outer space, because it's actually microatmosphere, it's not a vacuum, it's microatmosphere. The heat that is picked up from the sun is not radiated off, so you have to keep the shuttle cool somehow, and they talked about how they did that. The HP65 calculator kind of shows how we have changed technology, and the astronauts carried these things along just in case they had to figure it out on their own. So where are the shuttles today? Discovery is in the Smithsonian in Virginia. Atlantis is at the Kennedy Space Center. We saw it there. Endeavour is in Los Angeles, and I'm not sure where a couple of them aren't anywhere, unfortunately. And there was a number of just interesting things with the space shuttle as it had served its time, as they had served their time. Personal opinion, I think the movie Tomorrowland is a fantastic movie, and the storyline evolves about how the Kennedy Space Center, Cape Canaveral, is being taken apart, and someone's young lady is fighting to stop it. And a number of the things that were at the Johnson Space Center were things that were in use in the space program and are now being preserved, like this access arm, which you got to walk on and read how it was used, why it was used, the features of it. We're going to leave the access arm and give credit to the Kendall Tool and Die Incorporated, and move off to the shuttle carrier aircraft, the 747 that was modified to carry the space shuttle. And this is open quite a bit. It's also turned into a exposition hall or a learning center, whatever you want to call it. It was pretty cool to roam around inside this highly modified 747. There were two shuttle carrier aircraft. 905, NASA 905 was a former American Airlines 747, and NASA 911, which is at Palmdale, California, was Japan Airlines, and they were both highly modified to carry the space shuttles up on their racks. And because the interiors weren't needed, and because the interiors were weight, the interiors were stripped out, and to maintain center of gravity, to maintain control issues, ballasts were added. To maintain strengths, reinforcements were added. So there was quite a bit that was done to the 747, and a lot of it was explained in the aircraft itself as you toured the aircraft. As an educational exhibit, there was a lot of information in the aircraft about how it had been modified, the testing that was done. You saw the remote control aircraft.
You saw the model to dock the space shuttle on top of the carrier aircraft. You saw how much of the interior had been stripped out. The pressure bulkhead at the tail had to be kept so that the aircraft could be pressurized, because it was flying with personnel inside at the same time, plus the flight deck is not isolated, and it is, due to its size, required to have a black box, and all sorts of information is stored in those things. Ever wonder what brings you that fresh air when you're sitting in a 747? The air conditioning ductwork was visible in this aircraft, so that was kind of cool. Because you could roam around 905 and see quite a bit, you could see the landing gear, you could literally walk up to them and pet them if you wanted to, and walk around and get a distinct impression about how big a 747 actually is, and it is a monstrous aircraft. And it was very well presented for the purpose that it was, that its design after its life as an airliner, with this one with American Airlines, was to carry the space shuttle from wherever it had landed to back to Kennedy, so that it could be launched again. It was cool, impressive, and very well done. The process of moving it from Ellingston, where it landed, I believe that's where it landed, and over to the site, they had to take it apart, and that was very well documented, which is kind of cool to take a massive aircraft like that apart and then put it back together again. The Saturn V missile is in its own building. You take these shuttles off to it. These shuttles are free, and you don't have to stay with the group you're with. You can stay in the Saturn V building as long as you want. The Saturn V, as you're going to see, is actually in pieces, and we didn't find any docents in the area that were answering questions, so you just get to tour it around and take a look at it and see how big this thing really is. Multiple pieces. Each stage is identified as to what it does, when it does it, type thing, which was like really cool. And they were talking about numerous events along the walls, so it's another learning education experience, and it was pretty cool. We would, on our vacation, we would also visit Huntsville, Alabama, the missile capital there, and I forget his name, and I apologize for it. We found a really good docent who explained how these rocket engines, motors worked, and they took the fuel from the tanks and ran a small rocket motor, which provided a gas to run a turbine, which a pump, which powered a pump, which moved the fuel for the bigger engines. So they were using the fuel in two different ways. One, to run a small rocket engine, missile engine, which powered a turbine, and the turbine pumped the fuel, was used to pump the fuel into these nozzles. And these are all liquid fuel. Liquid fuel you can control. Solid fuel rockets like the SRBs for the space shuttle, once you light them, they go. Part of the presentation was past, part of the presentation was present, part of the presentation was future, and they were talking about going back to the moon, living on the moon, going to Mars, how they were going to do it, and the various things. One of the really nice things about it was, about the Saturn V presentation, was they identified each stage in great detail, or in very good detail, and where it operated, how it operated, type things. And this whole presentation of the Saturn V, taken apart like it was, so that you could see how they fit together, how they nested, because they had to be aerodynamic in the lower atmosphere of Earth. Once you got above the lower atmosphere, once they got above, say, 150,000 feet, aerodynamics didn't play much of a role. And this is also shown in the current SpaceX launches with the Falcon 9s. Once they get up a ways, they shed the fiberglass nose fairing for weight. As they stated, there's only 3 of these on exhibit. One of them here in Houston, one of them at Huntsville, and I suspect the other one is with the Smithsonian. It is a monster of a machine that accomplished a amazing task, and if you believe folklore, Werner von Braun, who's the prime architect of this system, actually intended it to take man to Mars, but the moon was our first stop, and that's where we took a long pause. There's what I'm going to call 2 missile parks associated with the Johnson Space Center in Houston, and one of them is just outside the Saturn V building, and you can see it in the background of this first missile, and the other one is out by the Space Shuttle and the shuttle carrier aircraft. And the signage was pretty good, and I think, quite honestly, I have screwed up the signs, but these were out in the weather. It was a rainy day, if you looked at some of the backgrounds and some of the photos. It was a rainy day, and I wanted to get photos, and I didn't want to get soaking wet. The way I kind of set this up was, I guess, by sections, and we moved into the section of various capsules, various missions, and how we kind of cooperated with the Soviet Union, the Russians, along the way. One of the things we learned, or finally figured out, was that for mutual safety, we needed to have a common docking system. I'm not sure if that's still in place with countries that are now launching into space, like China, India, whatever else, but I think with the Russian/Soviets, I think we do have a common docking system. So there was a number of things that had been used along the way that were no longer in use, that were put into the visitor center, which is a museum, and was interesting. A lot of signage about what happened, how it happened, who played the roles, and I really like the one I'm going to address here in a moment. I'm going to go off on one of my more infinite tangents, and this particular start was really interesting. Why no stars in the lunar sky during the Apollo missions? And that was because the Apollo missions were on the bright side of the moon, and just like on Earth, if you're on the bright side of the Earth and you look up in the sky, the only star you see is the sun. That's it. The other thing is, why did the flag vibrate? And this, the conspiracy theory people say this proves that this was done in the desert. Well, then you had to have a really, really big backdrop, because you had to cover up everything behind it, and there's some pretty dramatic scenes here. So to believe that this was filmed on Earth, to have the lunar rover and bounce and hop and skip as it did, throw up dust as it did, to have the astronauts do their leaps. At the time this was done, movies couldn't have done that. Sorry about that. The other thing is, people say, well, look at the flag. It was waving in the wind. The flag was basically tinfoil on a tape measure. And as you're moving around, you're vibrating the Earth, the soil, the lunar soil, and it's not real thick anyways. These guys were sinking into the soil 1.5 to 2 inches, even at their reduced gravity, weight versus mass, and the flag would occasionally vibrate because it was basically a tape measure for the mast. I love conspiracy theories. There was quite a bit on the Apollo missions to the moon, both successes and failures. Apollo 13, a failure in landing on the moon. It didn't. Success in the fact that it got the crew home. So there was quite a bit on the Apollo missions, which was extremely informative, and how they accomplished it, and how the 2 pieces went to the moon, the lander, and how only 1 piece came back, things like that. It was effective. It was thorough. The space race was a space race. The Soviets launched the Salyut, S-A-L-Y-U-T, which means salute in Russian, space station in 71. We launched Skylab in 73. It just seemed we were always just a little bit behind them. They launched the first astronaut. We put our first astronaut into a very high shot and brought him right back down again, but we caught up and we beat them. So it was a race, and Skylab was our effort to go into space and live in space for extended periods of time. We eventually brought Skylab home and splattered her all over Western Australia and the Indian Ocean. As the signage says, and the pictures are showing, we developed a system in space where we could stay for extended periods of time and learn those hard lessons of living in an environment that was absolutely not healthy for us, and that would later transfer off into what we would put into effect as the Skylab missions, not the Skylab missions, the International Space Station. Because Skylab was a working laboratory, we learned a lot about what it actually took to work in an open space, a larger space, rather than the confines of a capsule where all you had to do was reach over and grab something to anchor yourself, and so we were floating around. I was working on my aero degrees in 72 to 75, and because of my interest in space, I was reading virtually everything they published about these. Just because of my positioning, I tried to maintain some logic, moved off into the International Space Station, and it is truly international. NASA, the United States, the Russian Federal Space Agency, formerly the Soviet Union Space Agency, Japan, Canada, Brazil, and the European Space Agency, which is a consolidation of Austria, Belgium, Denmark, Finland, France, Germany, Greece, Ireland, and Italy, Luxembourg, the Netherlands, Norway, Portugal, Spain, Sweden, Switzerland, and the UK, which is one heck of a way to split the cost, decided that they were going to put up a truly joint scientific project, and it's absolutely huge. If you go on the internet, you can get apps that will tell you when the space station is going to be overhead your location, and the optimum time is just after sunset on the surface of the Earth, so that as the space station is traveling usually from west to east, the sun will illuminate it, and it is very visible, and it's probably about maybe a 30 to 40 second viewing, as it goes overhead. Binoculars work really well. Naked eye works great. Telescopes, because it's so small and moving so fast, unless you can track it electronically, use your eye. Space is not zero gravity. We refer to it as zero gravity because the gravity is so light, but space has a gravity. Something is always pulling on you, no matter where you go in the universe, so we believe. And it is also has an atmosphere. It's a microatmosphere. Because of that, because of those combinations, there is a resistance to orbiting vehicles, orbiting items, so they have to be restored. So the space shuttle, the International Space Station, as it's going around Earth, every once in a while has to have its orbit reset. It's slowing down. All these satellites that we have in space, if there's not a way to recharge them, reestablish their orbits, they're all going to slow down and come home. And when they do, it's going to be interesting. It takes a lot of thrust to lift 1 pound from the Earth's surface to orbiting height of something like the International Space Station. So how do we build things that are light and durable? And these were test panels of how do you protect the International Space Station. And if you watch any of the videos on the learning channels, history channels, science channels, whatever, you'll find that they will talk about the fact that they have evacuation drills or protection drills where they believe something is going to hazard the International Space Station, and all of the occupants have to go to hardened areas and seal themselves in airlocked areas, because if the skin of one section is ruptured, you have to make sure that it's isolated, just like a Navy ship, that it's isolated from causing damage to the rest of the structure. The progression I followed was they were growing food in space in the International Space Station, and part of that is, if we're going to live in space, if we're going to live on the moon, how are we going to survive? And the Johnson Space Center had a really nice display on, we're going to the moon and we're going to be living there for a while, and it's the Artemis mission, and that was my next presentation, and how we're going to get there. And numerous private companies like SpaceX, just one of them, are in the endeavor to get to the moon and to mine it. And the plans are being made, and we're finally going, and they're also planning on getting off to Mars. Mars is going to be a fun one, because due to the orbits and distances, we have to shoot at the right time to minimize the travel time there, and then how much time can we spend there before we have to come back to minimize our travel time return. Otherwise, if we're in the wrong orbit sequence, we're going to be en route a long time. Going to be interesting. So we're going back to the moon, finally, and we're going to the South Pole, because the scientists believe they've found frozen water at the South Pole, and it's going to be a interesting scientific venture as we go there. We're going to be using RS-25 engines. These are the same engines that the Space Shuttle used, liquid fuel. Same engines that the Space Shuttle used, and supposedly they're the best we've got going, and they're gonna take these things and send this thing off to the to the great beyond. Liquid oxygen, liquid hydrogen. So when you mix these two, you get water vapor. Expands many times off of its original storage when it goes from liquid to gaseous. The interaction of the two, and as I was saying earlier, there's actually an engine forward of this, that's using these same fuels to power a turbine, which is powering the pumps, and those pumps are what pump the liquid oxygen and liquid hydrogen into the nozzles at the right ratio so you get the thrust you so desire. Interesting concept, and the guy at Huntsville was the guy who explained this very, very well. For those of us that lived through this, the Challenger event, and saw all the photos, what's tagged to the Space Launch System is 2 solid rocket boosters. These solid rocket boosters are made by Northrop Grumman, not by the manufacturer for the Challenger. They've obviously been improved, enhanced, modified, adapted, all those other nice words to give us much, much more dependability. And that was an error of the O-rings were cold, they didn't seal, they ruptured, and the problem with solid rocket boosters, solid rockets, is once you ignite them, as a general rule, they go. There's no stopping them. I would imagine that somewhere along the line somebody developed a solid rocket fuel that you had to maintain continuous ignition, like a hot wire, and if you killed the wire then the fuel stopped burning. But I don't know of it, but I'm not a rocket scientist. I'm just a reader. Another area that I found extremely interesting in the Johnson Space Center in Houston was, we're going to Mars. That's an absolute in my opinion. We are going to Mars. I'm not sure exactly when, and part of this has to do with 2 planets, Earth and Mars, in their individual orbits at individual speeds, and how do we figure out how to get there, spend some time there, and get home, and yet still be in the same generation. So that's an issue. Whether the government does that or private guys do that, I think the government's going to do that in cooperation with the private guys due to its cost. But it's going to be interesting. And who are they going to send? Well, there's a lot of interesting people that you would want to send, and for that I would recommend you watch, and I referenced one of it before, watch the movie Tomorrowland. It's a Disney flick. And the second one to watch is Contact, and just watch them and look at the questions that are asked and the statements that are made and whatever, and then use your imagination. And who would you send to Mars? Because it's probably going to have to be a crew of, say, 8 or 10 people. You can't have a small crew. You have to have a crew that allows dynamics to be intermingled, because they're going to be together for a long, long time. And you have to have specialties. You have to have a doctor. You have to have a dentist who can probably be one person. You're going to have a psychologist. You're going to have a farmer. You're going to have a surveyor. You're going to have a pilot, a navigator. You're going to have at least a couple mechanics. It's going to be interesting. As I said earlier, there's 2 what I will call missile parks at the Johnson Space Center in Houston. One of them is by the Saturn V building, and if you look in the background of some of these shots, you'll see the Saturn V building. And the other one is out by the Space Shuttle and the Shuttle carrier aircraft. And in this, I hope I've got the engines right. I think I do. They're kind of interesting. I thought it was interesting, and there's a Falcon 9 sitting there, and there's some information about the Falcon 9 that's sitting there. It's retired. It's made numerous flights. You can see that it's a bit shop worn, and now down here. And as when I was working on my aero degree, my dad would tell me, to be a good engineer, you need to have an imagination, and you need to understand physics. And I think the guys that are working in SpaceX do both. What they've done, recovering stage 1, shedding the nose shroud to reduce weight once it's clear of the atmosphere, numerous things that NASA never ever did. wrapping up their Falcon 9 SpaceX missile and moving on to the OSIRIS-REx asteroid mission, where a spacecraft was sent to impact an asteroid, take samples, and bring the samples back, which is like kind of cool. We're getting stuff from a rock flying through space. Asteroids are rocks. Comets are ice with dirt and dust and other things in them, but asteroids are rocks, and they can be very, very small or very, very large, and this one was obviously large. Kind of picking up a few odds and ends that might be out of order, but the service module from the Apollo, how the fuel injector worked, which gave them the energy, and the old technology mission control out of NASA, and then the fuel cells. And between what the signage was at the Johnson Space Center in Houston and what I found on the internet, I was trying to figure out how these things work, and I think their presentation's clear. I just do not understand quite how it works. I just know it works, so that's like pretty cool. And meteors and meteorites. Meteorites hit the ground, meteors burn up in the atmosphere, and most meteors are smaller than a grain of sand. We don't even see them. The larger ones, grains of sand, we may see a streak across the sky. Their coloring of the trail depends on what minerals are in the meteor itself as it burns up. It's kind of cool. And the Johnson Space Center has several meteors and meteorites that you can touch and play with. They just ask you not to climb on them. Another interesting movie that, if you're interested in space, you need to watch is a movie called October Skies. It's one of those depictions of life, of somebody who wants to dream, and I envisioned growing up, I loved space, science, whatever, and October Skies is one of the really neat movies about guys that are growing up with the dream of space, and some of them made it. We thought these were cute. Standing around on the grass were a couple of deer, 3-4 deer, and according to the tour guide that was driving the shuttle taking us out to the Saturn V building, evidently there's an alligator that lives in the creek that you saw here. The facility also houses a FFA, Future Farmers of America, cattle project, utilizing the land. On September 4th, which I think was a Wednesday, we spent probably 4 hours at the Johnson Space Center in Houston. You've seen some of the photos we took. Extremely interesting place. I think it's child friendly because kids are going to ooh and ah, and there's a number of things that they can do there. Extremely interesting. I thought the signage was really well. It was a rainy day for us, so the outdoor signage had a bit of a glare to it. The indoor signage was pretty darn good, as in not a whole lot of glare, as you could see in the photos. Well worth it. Parking does cost. Admission is a bit high, but I mean it's an extremely well done presentation. Well worth it, and we really enjoyed our visit. If we're through the area, maybe we'll stop again. Thanks for watching. Hope you enjoyed it. Hope to see you in another one.